The third kind of factoring is probably the form that most people like the least. It's called standard form. There is a few good things that you can tell just by looking at the equation. Number one, we can tell that the a value means that this is going to stretch by a factor of 5. So instead of the parent function, which goes input 1, output 1, input 2, output 4, this one's going to have a multiplier of 5 for every y value. So it'll go over 1 up 5. The other thing that I know is that I'm going to have a y-intercept at 6 because that's my c value. So I'm going to go ahead and put that one on my graph. 1, 2, 3, 4, 5, 6. So down here my y-intercept is at 0 for x, 6 for y. Then I'm going to find my vertex. To find the x value of the vertex, we're going to do the opposite of b over 2a. My b value is negative 10, so the opposite of negative 10 is positive 10 over 2 times a, which is 5. So I have 10 over 10, which is 1. So my vertex x value is 1. So I know that my axis of symmetry is at 1. To find the y value, you can do a bunch of different things here. Most of you will probably put it in your calculator and look at the table of values. So we know 1 is our vertex, so I'm going to look at numbers bigger than 1 and a couple of numbers smaller than 1. I can also just go put 1 in for x. This is 1 squared is 1 times 5 is 5 minus 10 plus 6. So negative 5 plus 6 is 1, so my vertex is going to be at 1, 1. If I put 2 in, I have 5 times 2 squared minus 10 times 2 plus 6. This is 4 times 5, which is 20. Minus 10 is 10. 10. Let's see here. 2 squared is 4. Times 2 is 20. 20 minus 20 is 0, plus 6 is 6. And I know that's symmetric, so this must be 6. And then I'm going to put negative 1 in, so 5 times negative 1 squared minus 10 times negative 1 plus 6. So this is 1 times 5, which is 5. Negative 10 times negative 1 is plus 10 minus 6. So 15 minus 6 is 9. These are both 9. You can also put y equals in your calculator and type in the equation and take a look at the table. So 1, 1, at 2, I'm also at 6. So you can see again how this goes input 1, output 1, 2, 3, 4, 5, because this is a 5. This one has no zeros because it doesn't cross the x-axis. The domain is negative infinity to infinity. The range, the y value, it starts at 1 and goes to infinity. The vertex really tells us our interval of increasing and decreasing. As I come from the left to the right, it's decreasing from negative infinity until I get to 1, and then it's going to increase from 1 to infinity.